Originally, I had the idea to mount an ESP32 cam onto a toy drone, add an extra battery and you're done. Then I took a quick look online to see if there were already any useful tutorials for this. I quickly stumbled upon the term FPV, which was new to me, and just like that I fell down the rabbit hole. I realized that I was late to the party and that there are already real experts in this field. Nowadays, drones have camera systems that transmit image signals to goggles with very low latency. You can't get very far with an ESP32 cam. Most FPV pilots who take the hobby seriously build their drones themselves. In this video I show step by step how a drone is constructed. By the way, I did come across ESPs again along the way. I'll show you which systems exist, how to configure them, what legal aspects you need to consider, and how you can learn to fly a drone without risking an accident. You will see my improving flying skills and, thanks to growing confidence, also my first crashes. Thanks to self-built drones, these can usually be repaired or replaced just for a few euros, all the way to my own frame design for the 3D printer. A good entry-level drone is available for 250 euros. The ground equipment costs an additional 350 euro or so, but you have no idea what it feels like to control the drone and feel as free as a bird. Lows and highs, lows and highs, resistors, capacitors, mega-like. Well, this is not going to be a video about ESP32 cams. The first video I stumbled upon back then was this one from 2018 by the freestyle master Mr. Steele. It hasn't let go of me since. Back then the video transmission to the goggles was analog, that's a small image in the bottom right corner. The large image was recorded with an action cam. Modern drones now usually have digital FPV cameras, which provides a pilot with a better image, but they sometimes also have a certain latency. What Mr. Steele is doing here is called freestyle flying. Other pilots focus more on racing drones. But all of this should not be confused with cinematic drones like the popular products from the market leader DJI. They are very easy to operate, stabilize themselves in the air and can fly routes autonomously. The focus is clearly on high quality stabilized camera footage. Self repair is not intended for these high priced drones. The first steps towards FPV were apparently already taken in the 1990s, when analog video transmitters were mounted on model airplanes. An active FPV scene with drones developed in the mid-2010s, and still active American YouTubers like Joshua Bardwell, Mr. Steele and Botgrinder come from this era. So, back to freestyle drones. The Jumper T-Lite Mini remote control is available as little as 60 euros. I now have the high quality but over 400 euro expensive Goggles X headset from Kellex, which receives the digital video signal of the Walk-Snail system. There's now also the cheaper entry-level model Goggles L for the same video system, which costs 200 euros. Besides Walk-Snail, there are also digital systems from DJI and HD0, as well as analog video transmission. More of that later. For now, it's the best to take off in the simulator. I have tested the simulator's Liftoff, Uncrashed and Tribe FTV extensively. Liftoff was released as early access in 2015 and is considered very major. Even though it's no longer cutting edge graphically, it's a lot of fun and you definitely learn how to fly a drone with your USB connected drone controller. But to get ahead of myself, the other two simulators I introduce here are also suitable for learning. It's a bit like driving a car. The car from driving school probably drives a little differently than the car you own later, but you can quickly adapt what you've learned to the new vehicle. Similar, each drone simulator feels a little different, but real drones also have slightly different flight characteristics. Once you've internalized the basic principles, you usually get used to the new behavior after just a few minutes of flight and adapt accordingly. Tribe FPV was only released in 2022 and accordingly the graphics look more modern as they are based on Unreal Engine 5. With the recent update, the physics and flight behavior were significantly improved, but some minor bugs also crept in. In terms of graphics and fun though, it's one of the best simulators for me. The simulator Uncrashed is just as much fun, also based on Unreal Engine 5 and released in 2021. Updates are released very regularly, some with amazing new features. So far it's the only sim I know of where you can fly online races against other users. There's also a new editor that lets you build your own virtual tracks. In general, you quickly learn to appreciate the advantage of simulators. It's still fun to fly drones virtually even after you've flown a real drone. They each cost between 13 and 20 euros. But back to the real world. In Europe, the legal regulations for drones weighing less than 250 grams are much more relaxed than for the 500 to 800 gram heavy 5-inch drones. While looking for a drone, I stumbled upon the DIY tutorial from the YouTube channel Recursion Labs. If you don't want to buy a ready-made so-called Maiden Flight drone, but like me, prefer to tinker yourself, the build suggestion from Recursion Labs is, in my opinion, the perfect drone, not just for beginners. Since Recursion Labs video was too pre for beginners, I'll show it here in a bit more detail. Drone consists of an FC flight controller, a receiver for control, a camera system including transmitter, motors, and of course the frame. Here we use the frame of the Crux 35. The 35 in the name stands for 3.5 inch, which refers to the propeller size. The bottom plate of the frame is the part most likely to break if you crash. But at around 15 euros, the damage for the replacement part is limited. You can get the whole frame for under 20 euros. Assembly is simple. First, I screw the spacers onto the frame and prepare the FC, the flight controller board. It's the heart of the drone. All other electronic components are wired to it, for example the radio receiver, the camera system and the motors. The FC also runs a firmware called Betaflight, where you can configure everything. This is what's called an all-in-one board, because besides the actual flight controller, the so-called ESC unit is also on board, which is responsible for controlling the individual motors. Sometimes the ESCs are separate boards. The motors have 4 screws, which are also included in the package and connect the motor to the frame. Finding the optimal motors for a drone can be a challenge. However, Recursion Labs has done an excellent job with its construction proposal here as well. Each motor has 3 wires, which must be carefully shortened, stripped and tinned. The wires were neither labeled nor marked, and the order in which the 3 wires are soldered to the motor solder pads on the board is actually irrelevant for now. Later we can use the software to determine how the motors need to be controlled and then make a sensible configuration. Next, I solder the wires for the battery pack to the designated spots. The large capacitor is intended to cushion voltage drops. The receiver actually contains an ESP microcontroller and establishes the connection between the remote control and the drone's flight controller. ELRS has now become the new standard here, so it's best to make sure that both your receiver and the remote control are ELRS compatible. This is what the board with the FC now looks like. The receiver is now connected in a cross fashion with the receive and transmit pads and to the 5 volts and ground connections on the FC. The schematic diagram from the FC manufacturer provides precise information about where I need to connect what. I repeat the same principle for the camera unit. Incidentally, the FC can also work with other camera systems besides Walksnail. I continue and solder the XT60 socket for the battery pack to the already installed cables. Here you must absolutely pay attention to the correct polarity. The red cable, which is connected to the plus pole of the board, must go to the wider flat side. And don't forget to slide the sleeve or heat shrink tubing onto the cables before soldering if your socket has such things. The rather smaller batteries that I actually want to use here mostly use the XT30 sockets, which are half the size. Unfortunately, I realized this too late and had to replace this socket with an XT30 socket later. Once everything is sensibly wired, you can continue assembling the frame. The small receiver board can easily be attached to the main board with some adhesive putty. It was previously covered with heat shrink tubing, which, amongst other things, prevents the plugged-in antenna from slipping out due to vibrations during flight. The camera unit gets very hot when in operation and should therefore be mounted as openly as possible on the top part of the frame. And here I notice a dilemma with the oversized battery socket on the drone. As an interim solution, I use an adapter which I need for my charger anyway. So this is what it looks like for now. My self-built 3.5-inch drone in the sub 2050 class. It's important that all cables cannot get into the rotors. Unfortunately, I now realize that the camera angle cannot be adjusted upwards. This is due to the capacitor soldered too closely behind it. So I take everything apart again and solder the capacitor flat. On this occasion, I also add a buzzer and a GPS. If my drone crashes in tall grass, I can find it using the 100 dB loud sound of the buzzer and the GPS location. Later I will do without the GPS as it causes many problems and is hardly necessary. And I will later replace the buzzer with a model that comes with a small battery. Now, for the first time, I dare to apply power. You can use a so-called smoke stopper in between. It prevents damage to the electronics if you accidentally created a short circuit while soldering. Attention, when you connect the battery to the drone for the first time, or even you configure it via USB and need to connect the battery, you should always remove the rotors beforehand. Also, the camera system, the VTX, becomes very hot after a few seconds with the battery connected and can be damaged after a while. It's best to point a fan at the drone during this time. The configuration takes place in several steps. There are great detailed tutorials on this. I can generally highly recommend the videos by Joshua Bardwell. Nevertheless, I would like to briefly explain the essential settings. I configure the ESCs, this means the control unit for the 4 motors, via the website ESC-Configurator.com. Simply select the port and click connect and then read settings. Now I can see whether everything is correctly configured for my settings. If I later notice that the rotation of the motors is wrong, I can switch them from normal to reversed here. Many details can be found from the board manufacturer. My board, for example, is a GH30 with Blue Jay. I could adjust the settings if necessary. All required information can be found in the manufacturer's documentation. For my specific setup, these are the correct settings. At the end, click on Write Settings and disconnect. In the next step, I configure the flight controller. The firmware is open source and is called Betaflight. The associated desktop application is called Betaflight-Configurator and runs on all common platforms. To do this, the drone's FC is connected to the computer via USB again. Remember to remove the props if you also intend to connect the battery. However, the USB cable alone is not critical. I connect the drone with the connect button, activate expert mode and switch to the ports section. There I define which components I have soldered to which pins. For example, I connected the digital camera system to TX3 and RX3 according to the datasheet. Therefore, in Betaflight, in the line of the UR3 port, I select the peripheral VTX, which stands for video transmitter. Since I connected the ELRS receiver to the pins with the number 6, the button for the serial RX must be activated for UART6. Next, go to the configuration section. You can pause the video and copy my settings. By the way, I also have uploaded all settings on GitHub, the link is in the video description, so you can save yourself the clicking. But I will show you the next steps so you can see that it's not difficult. Here we have to set that the flight controller board is actually installed in reverse direction due to space constraints. Yaw decrease is therefore set to 180. Here are some more settings for the beeper. In the power and battery section, we mainly set that we are warned at a voltage of 3.55 volts. It's best not to fly longer than until a voltage of 3.5 volts per cell, then your LiPos will last quite a long time. The batteries can also briefly withstand 3.3 volts, but at lower voltages the batteries are heavily stressed and get damaged. Under failsafe, we can set what should happen if we press the corresponding button on the remote control in an emergency. Should the copter drop, land as controlled as possible where it is, or should it return to the starting point via GPS? The PID tuning section allows us to set under PID profile and filter settings how sensitively the motors respond to control. This is a science itself, and with the wrong settings the motors can overheat. For beginners, you should follow the recommendations of others for your motors. Under rate profile settings, use the standard Betaflight profile for now. Once you have more experience, you should definitely adjust the values to your needs. There is nothing to change in the receiver section for now, and in the mode section you can configure the buttons on your remote control. Under motors, you set what type of motors you have and can reverse the direction of rotation if they are spinning the wrong way by default. To make them spin, you must connect the battery beforehand, but as I mentioned, remember to remove the propellers first and point a fan at the video transmitter. Next, you can set which information you want to see in your on-screen display. The battery voltage is important. If the voltage per cell drops from 4.2 volts to 3.5 volts during flight, you should land. The settings for the black box are only needed if you want to optimize motor tuning. But now it's time to take off. My maiden flight is still tentative and shaky. Even though I already have around 20 hours of flight experience in the simulator and with my other drone, flight is still quite wobbly. The feeling of being able to fly as free as a bird is indescribable and can hardly be captured in a video. The fact that the image shakes so much when braking is related to the control of the motors. It's called prop wash or jello. This behavior can be corrected by fine-tuning the settings, which I did later of course. A few flight hours later it already looks much better. The video image can be recorded in the drone's VTX or with the goggles, but depending on the signal, the image quality of the goggles is usually a bit worse. Tricks like flips and rolls which you practiced in the simulator beforehand are a lot of fun. And of course, you always want to fly through bottlenecks and holes. It's best to find a meadow with soft ground because crashes are inevitable, and with soft ground you usually don't have to repair anything. By the way, I made some of the recordings with a slightly larger 5-inch drone. In my opinion, the difference between 3.5 and 5 inch is not significant, especially for beginners. Here I'm trying a power loop. My pulse goes up quite a bit. If you want to fly in Europe, you have to familiarize yourself with the EU drone regulations. The boundary conditions are precisely defined there. In Germany, for example, you need a spotter. This means a second person who maintains visual contact with the drone. The drone must therefore be visible to the naked eye at all times. However, you can join a model airplane club that allows flying without a spotter for a small membership fee. You are not allowed to fly higher than 120 meters without additional permission. Well, this is rather uninteresting for freestyle flying. You also need liability insurance. The drones shown here are often already covered by the normal liability insurance policies. For self-built drones and drones that weigh more than 250 grams, a so-called certificate of competence A1, A3 is required. You can do this online for 25 euros, and I would recommend it even if you don't need it because of your copter. You also need a UAS number, which you have to attach to your drone like a license plate. You can also apply this online for a few euros. And last but not least, you should download a suitable app such as Droniq for your smartphone, or use a website such as Dipul to see in which areas you are allowed to fly and where this is not allowed. For example, flying near airports or over nature reserves is prohibited. Because of the camera, you are not allowed to fly over other people's property, even with the light drones if there are residents there. But don't worry, there are enough public areas and nature left where you can fly and train. Keep your distance from other people in accordance with the rules and you will have a lot of fun. But what else do you need? You need a charger that can also charge multi-cell LiPos. This one is cheap, but they are definitely better devices. The LiPo batteries are available in various sizes and with a different number of cells. For the 3.5-inch Copter shown here, 4S batteries with 650 mAh are useful. The pros swear by the R-Line series from Tattoo. I use the cheaper China batteries from Droniq, which cost only about half as much and are not that much worse. The battery quality is also about how much the voltage drops when you accelerate hard. You can see my equipment again in an overview. On the left is my large 5-inch drone. It still carries an action cam, which you can almost do without nowadays given the good built-in cameras. Next to it is a 3.5-inch drone, which is actually completely sufficient in every respect. Also the goggles for the video system and a small lithium-ion battery pack that powers the goggles. And then the remote control that connects the drone to the ELRS protocol. The price of the drone itself that can break is quite manageable at around 250 to 300 euros. If you buy a drone with the analog video system, it will be even cheaper. And to be honest, the flying fun is identical. By the way, in addition to the large drones, there is also a category called tiny whoops, copters that usually weigh well under 50 grams and generally do not suffer or cause any damage in the event of a crash. Due to their weight, their flight behavior is somewhat different from that of the large drones, but they are also a lot of fun, and the almost non-existent risk allows you to make flights that would hardly be possible with large drones. They also still mainly use analog video transmitters. Search for guerrilla whooping. Pilots like Fpv Vegan show that you don't always need the big equipment to have great fun, even if the legal situation, at least in Germany, would not allow many of the flights shown here. Perhaps that's why Fpv Vegan's YouTube monetization was discontinued. Support him via Patreon if you like his content. Nevertheless, analog video systems are now considered obsolete by most freestyle pilots, at least for the large drones. If you want to buy a digital system, you have to choose between DJI, Walksnail and HD0 and commit to a system and a manufacturer. Unfortunately, the digital systems are not compatible with each other. In short, DJI has the best image quality in daylight, Walksnail is cheaper with equally excellent image quality, and HD0 has the best latency. It almost reached analog camera systems. I was initially concerned that the latency with Walksnail might bother me, but these concerns were completely unfounded. However, some experts and especially racing pilots see it differently, so it certainly depends on your own perception and skills. And while we are on the subject of skills, crashing is part of everyday life when it comes to freestyle flying, and sometimes something breaks. The spare parts usually cost only a few euros, but it's only fun if you enjoy repairing and tinkering yourself. And even if most crashes on soft ground have no consequences, it's worth having at least a few spare propellers, a spare motor and a spare frame ready. And it is recommended to have a loud beeper on your drone, especially when flying over high meadows or crane fields. Searching for a crash can sometimes be difficult. There are beepers that come with their own battery. Depending on the model, you can get them for around €3. With the 5-inch frames, you can usually replace the broken arms individually, while with a Crux 35 frame, you have to replace the entire bottom plate in this case. This happened to me twice in a quick succession, as you can see here. I wasn't prepared for this, so I didn't have another spare frame at first, so I designed my own frame for the 3D printer until the replacement frame was delivered. My 3D printed frame should have comparable rigidity with the lowest possible weight, so I determined the rigidity EI of the original frame. E is a material dependent Young's modulus, and I is the second moment of area. The original frame is made of carbon fibers. I print with ABS or PLA, which has a much weaker Young's modulus, so the second moment of area has to be correspondingly larger. This means that the frame must be much thicker than the original. If I print it hollow on the inside or with little infill, it will still be comparatively light. I use FreeCAD for the design. I have linked all the files for you in the video description. Printing is uncomplicated and fits the existing electronics without major adjustments. As you can see here, the frame is 16 grams heavier, but this actually has much less of an impact on the flight characteristics than I initially feared. As you have already seen, I have also designed a side guard. This is how the drone looks like now, and although the replacement frame has been here for a long time, I have now been flying with a self-printed frame for around a year, which has survived a few crashes and I don't miss anything. The flight time of the 3.5-inch drone is around 5 to 6 minutes with my battery size, depending on how aggressively you fly. With my 5-inch Copter, it is about 10 minutes. That doesn't sound like much, but believe me, as you wear the FPV goggles and are right in the middle of it, it feels good to take a short break after 5 minutes. The cinema drones from DJI fly much longer, but also use LFP batteries, which do not allow such agility by far. With a 3.5-inch Copter, you can see the propellers in the picture due to the design. This is often not the case with the 5-inch Copters like mine. Feeling like a bird is a great feeling, and whether you do it to record beautiful videos, to fly races or to practice tricks in freestyle, it's a hobby with a special fascination, and it combines the maker topics of electronics tinkering, 3D printing, software optimization with flying, which sometimes feels like a computer game but with a damn good graphics. I hope I have inspired you with my video. Don't forget to like and subscribe. Have fun with tinkering and see you next time.